Good morning to all. Today we'll be doing an activity based on Archimedes principle. But before we get into the activity, we must know what was the principle laid down by Archimedes and how did he get it. So the story goes like this, the anecdote goes like this. The King Hero 2 of Circus wanted a crown, a votive crown to be made for the temple. So he assigned a goldsmith for this. The goldsmith made a crown, but the king suspected if silver or some cheap metals were mixed in the gold, and the goldsmith kept the rest of the gold with him. He suspected if some other chemicals were mixed and that the crown was not of pure gold. So Archimedes was a very famous scientist during those times, during the time of King Hero 2 of Circus. So this king gave the duty to Archimedes. He gave Archimedes the duty to find if gold was mixed in it. Now Archimedes was thinking a lot, but he did not get any way to find it. And if he did not find, the king would be angry and he might sentence Archimedes to death. So he was thinking a lot and he did not get any way. So he thought he would confess that he cannot do that. And before he goes to the court to confess, he jumped, that is, he bathed. So he got into a water tub full of water. When he entered the water tub for bathing, he observed that some amount of water had been displaced. The level of water had increased, and when he measured the amount of water that had increased, he found that it was equal to the volume of himself, that is, the volume of the object inside the water. Now during that time's excitement, he was in that spur of a moment with adrenaline running through his nerves. He was very excited that he forgot to wear his dress, and he ran throughout the streets shouting Eureka. Eureka means I knew or I found it, something that is from a Greek word. Now what did Archimedes find? Archimedes found that when an object is dropped into water, an amount of water level increases, or it is displaced from the level, and that displaced water is equal to the volume of the object. He later found out that silver had indeed been mixed with the gold. That is, he took the gold and he dipped it in water and he measured the amount of the displaced water. He got some ml, that is, he got the volume of the object. Then he measured the mass of the crown. Now we all know that density is equal to mass by volume. So he measured the mass of the crown divided by the volume. He got a density which was not equal to the density of gold, and the goldsmith had to give his life to the king. Now that was the story. But the point here is to show that Archimedes' principle is true, or to prove that Archimedes was right. So let's enter to the activity. The first thing you need to perform the activity is water. I've taken a glass of water and I have marked the level of water using a rubber band. Okay, then you need a measuring cup. I have a measuring beaker with me, and a weight, the object you are going to dip. Now I did not have a proper weight, so I used a idle for this activity. Then you need a syringe to take off the water. As there was an unavailability of syringe, I did not get syringe, I will be using a pen pump. It works fairly good. Now the activity goes like this. I will be dropping the weight into the water. We see that the amount of water has increased. You can see that the amount of water has increased. Now I will be using this pen pump, the water off, and will be pouring it down to the beaker. Now you must make sure that not even one single drop of water falls down, because the amount of volume may change then. Okay. Now you can see that it has nearly reached the level of water, right? Yes. Now I repeat that the amount that I'm showing might be only approximate, because as you know, the water level might change. It's not that accurate, and some 1 to 2 drop of water might have gone down. Now you can see that the amount of water displaced here is nearly 15 ml. 1 ml or something less. So nearly 15 ml water had been displaced, and you can see that the level of water is as same as what we saw first. Now this is the volume of our object. So this is the volume of our object. Object has a volume of 15 ml. You can see that 15 ml means 15 cubic centimeter. That is 1 ml is 1 centimeter cube. So 15 ml is 15 cubic centimeter. Now this object is made of brass, and the density of brass is nearly 8.73 gram per centimeter cube. Density is equal to mass by volume. Density is equal to mass by volume. So we know the density is 8.73 gram centimeter minus 3, and the mass is what we have to find, and volume we found nearly 15. We'll take 14 centimeter cube. It was nearly 15, but we'll take 14. Now the mass will be 8.73 multiplied by 14, right? 8.73 multiplied by 14. Now when we calculate this, we get nearly 122.22. We get 122.22 gram. Okay, at 122.22 gram. Now I don't know the exact weight of this, but I believe that it would be nearly 122.22 gram. It's pretty heavy. Yes. Now that is how we find the mass of the object. Now to find the density, if you have the mass and the volume, you can find the density of the object too. Archimedes principle has a lot of applications. For example, it is used in submarines, it is used in lactometers, etc. Lactometer, which is used to test the purity of milk, and hydrometer, which is used to test the density of water, all are based on this principle of Archimedes. Now this is another activity. I've tied a rubber band to a weight. Now you can see that the length of the rubber band is very long, not very long, but it has increased due to the elasticity. The force acted on the rubber band, the force acting on the rubber band by the object is making it increase its length. But when I dip it into water, you can see that the length has decreased. It is not that noticeable because the object is far denser than water, so it is not that noticeable. But you can see if we use a spring balance that weight has changed, weight has changed a lot. A lot means more than what it was in the air. Now what can we say, or why is it happening? Archimedes said that when an object is dipped into water or is submerged into water, then an upward force by the water reduces or decreases the net force. So, in the air, the mass is different, and in water, it lessens. Not a very big change, but a change can be observed. A few milligrams or something can be observed. Now, this is what happens. We have a thread or a rubber band with an object. Okay, let us say that the force acting which we found using the spring balance, not the force, sorry, the mass, or no, the weight of the object, which we found using a spring balance is 10 gram, let us say. Okay, now when the object is submerged in water, an upward force is exerted on the object. Now, this force is 10 Newton, let us say, and this force acting on the object is, for example, 0.5 Newton, 0.5 Newton, which is acting on the object from the surface of the water, from the bottom of the water. The upward thrust is 0.5 Newton. Now, the total force decreases to 9.5 Newton. Please excuse my handwriting, but 9.5 Newton. Now you know that weight depends on the force acting. And thus we can say that the weight of the object has changed. However small the change is, the weight has changed. So, an object placed in a liquid will float in it if the weight of the fluid dispersed is equal to its own weight. So, the paper floats in the water. I don't know if you can see, but the paper floats in the water because the weight of the liquid or the water displaced is equal to the weight of the paper. Now, at the time of action of buoyant force and weight must form a vertical line. So, the line of action of buoyant force and weight must form a vertical line. This is called principle of flotation or the law of flotation.